Today we're talking about 6.2, which is different representations of functions. So let's start off with a little bit of a review. So this is kind of what we were talking about yesterday. So I want you to list the ordered pairs shown in this mapping diagram to the right, then determine whether or not the relation represents a function and to explain. So pause the video and try out this problem. Here's your answer. So this is the list of the ordered pairs. So we have 1460, 1457, 1255, 1552, and 1648. And then it is actually not going to be a function because 14 is, let's just say is, mapped to both 60 and 57. So since there's two arrows coming from an x, that means that it is not going to be a function. I have one more review problem for you. So I want you to determine whether or not the table represents a function and explain. So you're looking at this and seeing, is this table a function, yes or no? Hopefully you said no, because when I'm looking at my inputs or my x's, that's the only thing I care about. I don't care about my y's at all, but my x's I do care about. I'm seeing if there's any repeating numbers, and I see 7 on there 2 times. So since there's 2 different 7s for my inputs, I know that I do not have a function. If you can't see that from a table, feel free to make a mapping diagram. And if you have 2 arrows drawn from one number, that means that it is not a function. So the only last thing I have to talk about is this is going to be the high school way to do it. So before we were working with y equals mx plus b, we are no longer going to be using y. So when you have a function, we're going to be using f of x. So that's what this is right here. F of x. Let me write that out for you. F of x. That's what I'm saying there. So f of x equals mx plus b. It means the same exact thing. It's just a new way to do it that is more sophisticated because you guys are now 8th graders. So here's our rule. Instead of saying y equals mx plus b, we're saying f of x equals mx plus b. X is still our input, and then f of x is our output. So I've got 3 different sections that I'm going to talk about today, now that we've gone all over the pre-stuff. First section is talking about finding the value of the function f of x for the given value of x. So we have a function right here, and then it says find for f of 4. And so if you notice, it's kind of sort of the same thing, and that's purposeful. So when I'm solving these kinds of problems, I'm going to write, that is really thick, give me a second. So if I'm finding f of 4, what I'm going to do is I'm going to replace this x with a 4. So instead of saying f of x equals 2x plus 5, I'm saying f of 4 equals 2. Instead of x, I'm going to write a 4 and then plus 5. And then I'm going to simplify it. So 2 times 4, we have to do first, which gives me an 8 plus 5. Let me copy this all down. And then we're going to add those 2 together. 8 plus 5 gives me 13. And so I've simplified this equation, and I'm saying for my final statement that f of 4 equals 13. And that's going to be my final answer. We're going to do the same thing for this problem over here. So it says f of x equals half of x minus 9. So just like before, I am taking away all of my x's and replacing them this time with 8 because I'm finding f of 8. So anytime that I see an x, I'm replacing it with an 8. Sorry for my horrid handwriting. Okay, so now that we've substituted, we're going to go ahead and simplify. So I see multiplication here and then subtraction here. So I'm going to do the multiplication first. Half of 8 is 4. And then we still have minus 9. 4 minus 9 is going to give me a negative 5. And that's my answer. So f of 8 equals negative 5. All you're doing is substituting that number into our function and then simplifying it. So why don't you try these next two problems? So pause the video, try them out. Feel free to rewatch me teaching the last two problems. And here's your two answers. So for the first problem, when we substitute in 9, we get f of 9 equals 13. And then for our second equation, or for our second function, I should say, when we substitute in negative 3, we get f of negative 3 equals negative 4. Now we're moving on to section 2. So it says write an equation that describes the function that's shown by the table. So it's telling us that this is a function, which means we have a pretty good chance of writing an equation from this function. So we are always going to start off with our f of x, just like how we did when we were working with equations. Except with equations, we did y, now we're just doing f of x. So you can always start off writing that. When we're writing an equation, we are looking for our slope, which is our m, and we're going to look for our b, which is our y-intercept. We're going to be able to find slope by looking at the change in y over the change in x. So m is, that was rough, there we go. M is the change in y over the change in x. And those triangles mean change. So we're looking at how much y changes. It changes by a positive 4. And we're looking at how much x changes. It changes by a positive 1. So that means for this equation, for this function, our change in y is 4, our change in x is 1, so our slope is 4 over 1, or you can just simplify it to 4. So we're going to start writing our function. F of x equals our m, we figured out, is 4. We still have our x plus, now we have to figure out what b is. So I said b is our y-intercept. When we're thinking about our y-intercept, I'm thinking about where our graph crosses at y. So that means we have to look where y is 0. We're looking at x. So y is 0 right here, and our x is 0 actually at the same time. So technically it's going to be plus 0, but you can always just write f of x equals 4x, because that's simplifying this function right here. So let's write another equation that describes this function. So again, it's going to be in that same format. F of x equals mx plus b. Again, we figure out our slope by looking at the change in y over the change in x. So I'm going to see how much y changes each time. It looks like it's going down by 2. So our change in y is a negative 2. Our change in x, it looks like it's changing by a positive 2. So we're going to put a positive 2 in the denominator. We're going to simplify that. 2 divided by 2 is 1, and negative divided by a positive is a negative. So we have a negative 1 for our m. So let's fill out that information. So we're going to replace the m with a -1, keep our x, and then we have to figure out what our b is. Remember, b is where we have our y-intercept, or where y is 0. So currently, I don't see 0 in this table, but we can get there. So if I go this way, I'm going to continue going down in numbers. I know to get to 0, I have to go up. So I'm going to go up 2. And that's going to get me to my 0. Whatever I do to one, I have to do the other. So this one, I went up by 2, so I'm doing the opposite. So I'm going to subtract 2. 1 minus 2 is -1. And that's where our y-intercept is, because that's where y equals 0. So I know my y-intercept is going to be a -1. There's nothing to simplify there, so we're just going to say that that is our function. Now it's your turn. I would like you to write an equation that describes the function of this table here. Hopefully you got f of x equals 6x, and then you could add a plus 0 if you would like, but to simplify it, we're just going to have that 6x there. Okay, we're on to part 3, so this is our final part of our notes. So I want you to write a function rule for the statement, and then I want you to complete the table afterwards. So let's read this statement. It says the output is 5 less than our input. So let's break that statement down. So when I say the output, I mean y or f of x. When I say is, that usually means equals. 5 is a number. Less than refers to subtraction. And then our input is going to be x. So the output is 5 less than the input. So I know a function always starts off with f of x. So I'm going to put that there. And we've used the output. Is means equals. So we've used that. And then 5 less than the input. So I have to think about what number I'm starting with. If it's 5 less than my input, that means my input is my starting number, and I'm going down by 5 after that input is entered. So that's 5 less than our input. And that is our function. So let's go ahead and complete the table like it says for this to do. So we are putting in 1 minus 5, because that is our rule. So 1 minus 5 is going to give me a negative, that should say 4. So -4 is my output, which makes sense. I'm just double checking. It says the output is 5 less than the input. This is my input, this is my output, and that is 5 less. So I know that I did it correctly. Let's do it with our 2 now. F of 2 is 2 minus 5, which is going to simplify to a -3. Same thing with our 3. We're plugging that in. Substitute that in for x. So we've got 3 minus 5, which is going to give us a -2. Last one with the 4. Substitute it into our x. And then we've got 4 minus 5, which is going to give us a -1. And we've completed our table. So we wrote our rule, which is right up here, and then we completed our table. So we are done with this problem. Now it's your turn. So write a function rule for that statement. The output is half of the input, and then complete our table. So try that out on your own. So there were two different functions that you could have said. You could have said 1/2 times x, or you could have said x divided by 2. It means the same exact thing. And so when you're writing statements like these, sometimes it gets a little bit confusing on what you're supposed to do. If you make yourself a table with a bunch of inputs, you can test your equations to see if they make sense and they match up with that statement. So 1/2 of 2 is 1, 1/2 of 4 is 2, 1/2 of 6 is 3. And so I know that I made my equations correctly because when I put these numbers into my equation or into my function, it gives me the solution that I want to get. Because I know I can do this in my head, but I want to create a rule so I could pass that information on to somebody else. And then here's your homework. So you are doing page 253, numbers 4, 5, 6, 7, 8, 9, and then 13, 14, 15. If you have any questions, please send me an email.